हेलो बच्चों। बच्चों अब हम स्टडी करेंगे हमारी जो थर्ड प्रॉब्लम आती है जो कॉन्करेंसी की वजह जिसका नाम है अनकमिटेड डिपेंडेंसी प्रॉब्लम, उसको देखते हैं। तो प्रॉब्लम से पहले मैं बता दूं जो हमारे पास सेकंड प्रॉब्लम थी डर्टी रीड प्रॉब्लम और जो थर्ड प्रॉब्लम है अनकमिटेड।
Let us discuss three terminologies mainly. They are failure, error, and fault. We might be feeling that they are having the same meaning, but not in the case of reliability or reliable, these terminologies are not having the same meaning. So let us discuss one by one. So at first we are going to discuss failure. The failure of a system occurs when the system does not function according to its specifications. In our earlier videos, we have discuss what is reliable and what is reliability. Each and every system will take some inputs and produce some outputs. But whether the outputs are meeting with the pre-decided specifications, is it so? That is, you see, when it is not meeting with the pre-decided specifications, and according to specifications, if the services are not provided, then it is called a failure, and it fails to deliver the service for which it was intended. So that is known as a failure, where the service quality is not meeting with the specifications given or decided. Next one, we are going to discuss error. An error in the system occurs when a component of the system assumes a state that is not desirable. So component of the system will be found in a certain state which is say that it is not desirable. Obviously, the fact that the state is undesirable is a subjective judgment. So that will depend whether you are taking that one, that whether this component is in a proper state or not, that is your decision. So it is a subjective judgment rather. Fault. A fault is detected either when an error is propagated from one component to another component, and failure of the component is observed. So that means when one error will propagate from one component to another component, then we shall say that one fault has detected. That is one. Fault, and failure of the component is observed, and that will be also another case of detection of a fault. Now, what is a fault tolerance system? Sometimes we introduce redundant components into a system so that whenever a component will fail, then from the redundant components we can take that component as a backup so that the system can work. See, fault tolerance system. In addition to fault detection scheme, this system, that is a fault tolerance system, has redundant components and subsystem built in. On detection of a fault, These redundant components are used to replace the faulty components, and system will go on. We're discussing types of failure. These types of failure may occur in multiple different categories. So we shall discuss all these categories and their respective varieties and respective various causes. So here is the text. We can categorize these types of failure. failure mainly into four heads. One is the hardware failure, next one is the software. We're discussing the topic audit trails. The question is coming in mind, what is audit trail? Audit trail is nothing but one record which will be generated against each and every transaction. And regarding the transaction, it will keep certain information. The information can be categorized in this way. Thus, who has initiated, where it has got initiated, when it has got initiated, and what is the purpose. So in this way, it will give mainly, it will give four answers against four questions, that is who, what, when, and where. So let us go for the detailed discussion regarding this. So here is the respective note. The audit trail records who. Who means the user identification number, or the application program who has initiated, or the transaction ID. So user or application program and transaction number. So that will be answered. That will be this particular data will give you the answer, that is who. So audit trail will keep this particular information who. Next we are going to discuss when. When means it will just take the respective time and the date, that when this particular transaction got initiated. Next it is coming from where. That means from where, which location this transaction got initiated. So location of the user and or the terminal. And what? So that is the fourth question it is asking. What? What means the identification of the data affected, as well as a before and after image of that portion of the database that was affected by the update operation. So it will keep the before and after image of that particular portion of the database which is getting affected due to this update operation. So that later if you go for the rollback, we can get back the previous instance. So that is also very important. That is the what, that is the identification number of the data affected, as well as before and after image of that portion of the database that was affected by the update operation. Okay. In addition, a DBMS contains routines that make a backup copy of the data that is modified. This is done by taking a snapshot. This is a very important term. Questions might be coming separately on this particular terminology, that is a snapshot. So what is a snapshot? So snapshot of the before and after image of that portion of the database that is getting modified. For obvious reasons, the backups are produced on a separate storage medium. So in this way, we're getting the idea what is a snapshot, and obviously we're getting the idea that what is an audit trail. Thanks for watching this video. Here we are discussing a topic that is known as the recovery schemes. Let us suppose a failure has occurred in the system and the current transaction has got aborted. How to get
Hello student, today my topic is distributed DBMS reliability. A reliable distributed database management system is one that can continue to process user requests even when the underlying system is unreliable. In other words, even when components of the distributed computing environment fail, a reliable distributed DBMS should be able to continue executing user requests without violating database consistency. So here another definition is a reliable DBMS is one that continue to process user requests even when the underlying system is unreliable, that is, failure occurs. So we can write here like this: data replication plus easy scaling is equal to reliable system. Distribution enhances system reliability. Need number of protocol to be implemented to exploit distribution and replications. Reliability is closely related to the problem of how to maintain the atomicity and durability property of transactions. Second is system, state, and failures. In the context of reliability system refer to a mechanism that consist of a collection of components and interact with its environment by responding to stimulate from the environment with a recognizable pattern of behavior. Each component of a system is itself a system, commonly called a subsystem. The environment of a component is the system of which it is a part. The way the components of a system are put together is called the design of the system. Here, reliability refers to a system that consists of a set of components. The system has a state which change as the system operates. The behavior of the system, specification indicate the valid behavior of each system state. Any deviation of a system from the behavior described in the specification is considered a failure. The internal state of a system such that there exist circumstances in which further processing by the normal algorithm of the system will lead to a failure which is not attributed to a subsequent fault is called erroneous state. The part of the state which is incorrect is an error. An error in the internal state of the component of a system or in the design of a system is a fault. This diagram shows fault to error. Each failure obviously need to be traced back to its cause. Failures in a system can be attributed to deficiencies either in the component that make it up or in the design, that is how these components are put together. Each state that is a reliable system goes through a valid in the sense that the state fully meet its specification. However, in an unreliable system, it is possible that the system may get to an internal state that may not obey its specifications. Further, transition from this state would eventually cause a system failure. Such internal states are called erroneous state. The part of the state that is incorrect is called an error in the system. An error in the internal state of the component of a system or in the design of a system is called a fault in the system. Thus, a fault causes an error that result in a system failure. This figure shows the chain of the events leading to system failure. Fault causes error resulting failure. Types of fault. We differentiate between errors like faults or failures that are permanent and those that are not permanent. Permanence can apply to a failure, a fault, or an error, although we typically use the term with respect to the fault. A permanent fault, also commonly called hard fault, is one that reflects an irreversible change in the behavior of the system. Permanent fault cause permanent error that result in the permanent failures. The characteristic of these failures is that recovery from them requires intervention to repair the fault. System also experience intermittent and transient fault. In the literature, these two are typically not differentiated. They are jointly called soft fault. The dividing line in this differentiation is responsibility of the system that has experienced the fault. This figure show the classification of fault. Design fault together with unstable hardware cause intermittent error which result in system failure. A final source of the system failure that may not be attributable to a component fault or a design fault is operator mistake. These are source of significant number of error as the statistics include further in this section demonstrate. The relationship between various types of fault and failures are given in the figure. To show the different types of faults: permanent fault, incorrect fault, unstable managerial component, unstable environment, operator mistake. These all distinguish into permanent, intermediate, and transient errors. Now, reliability and availability. Reliability refer to the probability that the system under consideration does not experience any failures in a given time interval. It is typically used to describe system that cannot be repaired or where the operation of the system is so critical that no downtime for repair can be tolerated. Availability refer to the probability that the system is operational according to its specification at a given point of time. The fraction of time that the system meets its specification, the probability of the system is operational at a given time t. Here, the reliability of the system RT equal to PR, 0 failure in the times, no failure at t equal to 0. If occurrence of the failures in the Poissons, then formally the reliability of a system RT is defined as the following conditional probability: RT equal to PR, 0 failure in time, 0 t, no failure at time t. Reliability theory as it applies to hardware system has been developed significantly with the help of this formula. Now, the expected mean number of failures in time 0t can then be computed as, with the following formula we can find the mean expected, which is mean number of failure in times. With the help of this formula we can find, and its variance, the variance can be computed with this formula, and the reliability of single component is RT equal to e to the power minus mt, and of a system consisting of an n number of non-redundant components. With this formula we can find it. Availability, which is denoted with AT, refer to the probability that the system is operational according to its specification at a given point in time t. Several failures may have occurred prior to time t, but if they have all been repaired, the system is available at time t. Availability refers to the system that can be repaired. If we assume that the failure follow the Poisson distribution with a failure rate and that repair time is exponential with a mean repair time of 1 by mu, then the steady state availability, with the help of this formula we can find it. Availabilities, we can find this formula. Now the next one is mean time between failures, mean time to repair. Calculation of reliability and the availability functions is quite tedious. It is therefore customary to use two single pair matrices to model the behavior of a system. The two measures used are mean time between failure and the mean time to repair, which is denoted with MTTR, and mean time between failure, MTBF, that is denoted with this. The MTBF is expected time between subsequent failure in the system with the repair. MTB can be calculated either with empirical data or from reliability function, as with the help of this formula. If it is related to the repair rate, as MTBF is related to the failure rate. Using these two metrics, the steady state availability of a system with the exponential failure and the repair rate can be specified as A equal to MTBF equal to MTBF plus MTTR. System failure may be latent in that failure is typically detected sometime after occurrence. This period is called error latency. An average error latency time over several identical systems is called mean time to detect, MTTD. With the following figure, you can see occurrence of event over times, how it works, you can see.
Hello guys, I'm back with our next lecture. In this lecture, let us go through the third unit of distributed system. So in this unit, we'll be discussing the concepts of a fault tolerance as well as a distributed object based.
system, guys. Okay. So first, let us start with the introduction of fault tolerance. So basically, what is a fault tolerance, and what are the things that we will be considering with respect to fault tolerance are the things which we will be discussing in this lecture. Okay. Yes. Okay. So basically, what is a fault, guys? Before going into tolerance, also let us first understand what is fault. So basically, fault is something due to which there could be something happening, something bad is happening. Okay. So in that way, so assume that you bought a computer or you bought something. So they told that there is a fault in the system like that. So there is something bad which could lead to something, right? Yes. So here what you will be trying is nothing but fault tolerance means you are trying to stop it. So basically here you will be trying to stop that issue. Okay. Yes. So when it comes to distributed system, the definition will change a bit, guys. Okay. Yes. So basically the concept of fault tolerance says that whenever, assume that there is a system, guys. Okay. So inside which there are two RAMs. Okay. Okay. So due to some technical issue or something, the first RAM has stopped functioning, guys. So it's not working. So some kind of electrodes or some kind of issue has been occurred and it's not working now. So basically, even under its non-working nature, the system should continue, guys. There should not be any issue with the system. So this is nothing but the concept of fault tolerance. So fault tolerance is the property that enables a system to continue operating properly in the event of a failure or one or more faults within some of its components. Okay, I hope the definition is a bit clear now. Okay. So let us continue. So being fault tolerance is strongly related to what are called dependency systems. Okay, so there are few features, guys. Those are nothing but availability, reliability, safety and maintenance. So basically by using these kind of things, we can achieve the chances of fault tolerance. Okay. Yes. So firstly, availability. So I hope everyone knows what is the meaning of availability, right? Yes. So availability is nothing but the system should be ready all the time. So availability is defined as the property that a system is ready to be used immediately. So basically assume that you opened your Google Chrome and you typed google.com. So initially once you type google.com, the request will be sent to the server. Some path will be there, like from you to the internet service provider, from there to DNS and all those things. I'm saying directly. So it is sent to the server and server will reply instantly, right? It will be very fast. So it is replying very fast means it is available. It is always available for service. So in that way also you can remember. Okay. Yes. So a highly available system is one of that will most likely be working at any given instance of a time, even after failure. So basically assume that the Google server is being updated. Okay. So update is done. So you refresh the page. So at that instance only you will be getting the page available. So in that way, so it is that much fast, guys. Okay. Similarly, reliable. So reliable is really easy to understand, guys. Let us go to the definition. So reliable refers to the property that a system can run continuously without failure. Okay. So few of you might be confused with between reliability and this, guys, availability. So I'll be giving you an example. So don't worry. Okay. Okay. So reliability refers to the property that a system can run continuously without failure. So please understand that here we are saying continuously. Means it should not have any any failure in between also. That is the main thing here. Okay, a highly reliable system is a one that will most likely continue working without any interruption. So there should not be even a millisecond or microsecond also. Okay, so then you can say that the system is reliable. Okay, so let us take an example. So if a system goes down 1 millisecond every 1 hour, so basically you are having some network you are having some transactions or anything you are doing, guys. So basically for every 1 hour, in 1 hour span, for a particular amount of time, that is 1 millisecond, the server will be down, guys. Okay, yes. So in this situation, what can you say? So here you can say the availability of the server or the system is a 99.99, but it is a highly unreliable, guys, because you cannot work continuously, right? So you worked for a long time and you submitted your data or anything at that millisecond only. It's just waste of your time, right? So that is the reason why you can say that this system isn't reliable. Okay, so I hope everyone got some basic idea about availability and reliability. So the thing is, in reliability, it is continuous time. That's the thing that you should remember. Okay, yes. Similarly, safety. Safety refers to the situation that when a system temporarily fails to operate correctly, nothing bad or dangerous will happen. So safety is nothing but any kind of issue, guys. Okay, yes. So there could be, sometimes it will be happening, right? So whenever there is any kind of short circuit in your home, the computer might explode, right? Yes. So in that there could be multiple, like AC vents, like there are many reasons, right? Yes, even bulbs also sometimes, right? So that is the reason why you need to be safe always. Okay, okay. So all the systems should be in the safe way and they should be in normal way. So sending people into a space requires a high degree of safety. If such a control system temporarily fails for only a very brief moment, the effects will be disastrous. Okay, so assume that NASA or some other space stations are sending rockets. Okay, rockets. Okay, so they will be keeping countdown and all those things, right? So even a second late or second delay, the rocket might not go and there could be various issues, guys. So that is the reason why they'll be using real-time operating systems. I think operating systems also we discussed. So they'll be using real-time operating systems which are really fast when compared to any kind of operating. They will be reacting at that moment like that. So that is nothing but safety. So they'll be taking multiple safety precautions and all those things will be taken, guys. Okay. Similarly, maintenance. So basically, maintenance is nothing but you can say, right? So they will be saying even for websites they'll be taking maintenance and all those things. So basically, they'll be checking the status, like it is working fine or not, and everything will be taken back up and all those things will be done, guys. So maintenance refers to how easy a failed system can be repaired. So how easily a failed system can be repaired. Okay. Yes. So I hope everyone got some basic idea on fault tolerance. So in the next lecture we'll be discussing about some types of faults, guys. Okay, so let us meet in the next lecture. Thank you. Thanks for watching. Hello guys, we are back with our next lecture. In this lecture, let us go through the types of faults. Okay, so we are having 3 different types, guys. So just by the names only, few of you can identify them. Okay, so the first type is nothing but a transient fault, guys. So transient fault is nothing but it is some kind of guess you can assume in that way. So it comes for some time and it's vanished without its intimation. Like transient faults occur once then disappear. So they magically vanish from there. Okay, yes. So an example could be a bird flying through a beam of microwave transmission causing loss of bits. So basically assume that the data is transferring in this particular in air. Okay, so assume that there are microwaves. Okay, microwave transmission. So assume that a bird came in between, so the bits are lost. So this kind of bits will be corrected. So this is nothing but transient because the bird will not come every time, right? So there could be a chance, right? Yes. So this is nothing but transient and it occurs rarely. Okay. Similarly, intermediate fault. So fault occur, then vanish of its own occurred, that reappear again. Okay. Yes. So basically some kind of loose connections you can say. So basically it will work for some time and again it stops working. Again after some time it will start working, guys. So sometimes whenever our remotes, TV remotes and all those things, whenever they are battery low, these kind of issues will also come, guys. For some time it will be working and for others half time it will not work. So in that way, that is nothing but intermediate. Okay. Yes, I think I wrote it in the wrong way. So please correct it on your own, guys. Okay. Yes. So permanent. So permanent are nothing but you need to replace them. Like it's a permanent fault. Okay. Okay, so continue to exist until the fault component is repaired. So basically assume that your processor, in your system, the processor or anything has been damaged. There's no chance that your system will run now. If your RAM damaged, it could run. But if processor, like some kind of main components, if they damage, you cannot run the system, or you can't even turn on the system, guys. Okay, so that is nothing but a permanent fault. Okay, so I hope everyone got some basic idea on 3 different faults. So in the next lecture we will be discussing some basic examples of failures, guys. Okay, so let us meet in the next lecture. Thank you, thanks for watching. Hello guys, so back with our next lecture. In this lecture, let us go through failures, guys. So there are some classifications in failures. That's the thing which we'll be discussing in this lecture, guys. Okay, yes. So the first type of failure is nothing but crash failure. So basically from the name only you can see, so there is a server crash or some kind of crash. Yes. So a server halts, that's nothing but server crash, but it works correctly until it halts. So basically assume that a transaction is going on, and it is done. Okay, and now the server has been crashed. So you can safely say that the transaction has been successfully completed and the server has been crashed without any issue, right? Yes. So basically before it's a crash, everything is fine. So in that situation you can say it is called you can call it as a crash failure, guys. Okay, similarly omission failure, guys, please remember these words, guys, because there are 3 words with omission, that is nothing but omission failure, receive omission, and send omission failure. Okay, yes. So omission failure, so a server fails to respond to incoming requests. So whenever there is an issue with the incoming requests, then you can say that it is nothing but omission failure. Similarly receive omission failure, so it is nothing but a server fails to receive the incoming messages. So here it is responding, here it is receiving. Okay, similarly send omission, a server failure to send messages. So basically here the server is failed to send a normal messages. Here it is nothing but respond to incoming messages, receiving incoming messages, sending messages. So there are 3 different, guys. Okay, yes. Similarly timing failure, so basically assume that there is a deadline given for your something like project or anything, so they gave 3 hours like to code in your examination. Okay, so you coded, you executed the code, but it was late, so that is nothing but time failure. So a server lie outside the specific time interval, so basically not in the time interval but outside, so that is nothing but time failure. Okay, similarly response failure, value failure, and state transmission failure. So these 3 are a bit related, so that's the reason I have divided them, guys. Response failure, a server response is incorrect. So here we are saying response failure, so basically the server gave something wrong information. Okay, yes. So it could be some kind of profile also. Sometimes whenever you open your profile you might be getting some other names, right? So it occurs rarely, but there is a chance, right? So that is nothing but response failure. It responded in the wrong way. Similarly value failure, the value of the response is wrong. Yes. State transition failure, so basically the transition states, like the flow is completely in a random way or some kind of wrong way. The server deviated from the correct flow of the control. Yes, that's what I was trying to say. Similarly arbitrary value, a server may produce arbitrary response to arbitrary times. Okay, so it's giving multiple values. So if you asked the first time, it told x equal to 10, the value of x is 10, and there is no update or no any kind of operation, and again you asked it is saying 20. So in that situation you can say that is not but arbitrary value. Okay, yes. So I hope everyone got some basic idea about these failures. So in the next lecture we'll be discussing about failure masking by redundancy, so how you can resolve some kind of failures. Okay, so let us meet in the next. Hello guys. Okay, back with our next lecture. In this lecture, let us go through the concept of a failure masking by redundancy, guys. Okay, so how you can omit or how you can hide these failures from other systems or other processes, right? Yes. So the idea is to hide failures from other processes using redundancy. So redundancy is something like you are storing something redundant, like existing only you are storing again, or you are wasting some space, but you are resolving these failures, right? Yes. So that is the main advantage here. Okay, so first let us go through information redundancy. Guys, I think we discussed about this topic previously, but I will just give you an introduction. I will give revising it here again. I think in computer networking we discussed about Hamming code, right? Yes. So basically, whenever a message is being sent, okay, so assume that you sent 1010. Okay, yes. So this is your message, right? Yes. So with this message, you will be sending some more data, guys. So this could be some kind of a data. It could be redundant data or any kind of data. Basically, redundant data is nothing but some kind of bits. That's it. There is no specific thing for them, but they help in correcting the message, guys. So if this message is corrupted, this will help. This combined will help in resolving that issue. So that is the use of this Hamming code, guys. Okay. Yes. So it is used in error correction and error detection also, guys. Yes. Okay. So with information redundancy, extra bits are added to allow recovery from the mixed bits, like any kind of garbage bits and all those things. Okay. Yes. Similarly, time redundancy. Guys, I'm not that much clear with the time redundancy, so I'll be just reading a definition. I'll be explaining as per my understanding, guys, because I am not clear with it. I don't know exactly whether it is correct or wrong also. Okay. Yes. So time redundancy. So an action is performed, and then if needed, it is performed again. So basically, assume that in a specific time there is a particular task. Okay. So you completed it in the first half only. Okay. And the system told that there is some issue, please redo it again. Even though you did successfully, you will be redoing it again. Means you are indirectly repeating the things, right? So that is nothing but redundancy, right? So that is time redundancy. So in a specific time, you are doing the things repeatedly. Yes. Okay. Similarly, physical redundancy. So I'll be giving a best example for this, guys. Okay. Okay. So physical redundancy is nothing but the physical objects or physical components. You will be buying them extra. You will be taking them extra. So basically, you might be having a doubt. So why should we take them extra? Okay. Yes, I'll be giving an example. So basically, assume that you are doing some IoT project. Okay, and you need some components. Okay. Yes. So you need you need 6 components. Assume in that way, among which 3 components are really hard to use. So basically, there is a high chance that there could be some issue in them. Okay. Yes. So these 3 are compulsory. They are working. Whenever you are buying, you tested them, but these 3 you did not test. Okay, and the shop like where you bought them is online or it is too far, these 3 items. So instead of buying one, you will be buying 2, guys, because if one failed, the other might work, right? So this is nothing but physical redundancy. So you are buying 2 components instead of one to be on the safe side. So you are masking the failure, right? Yes. So this is physical redundancy, guys. Okay. So I hope everyone got some basic idea about failure masking by redundancy. So in the next lecture, we will be discussing about process resilience, guys. Okay. So let us meet in the next lecture. Thank you. Thanks for watching. Hello guys, we are back with our next lecture. In this lecture, let us go through the concept of a process resilience, guys. Okay. So first, before going into resilience and all those things, first let us go through some basic definitions, guys. Because resilience is completely dependent on fault and so that. Okay. Yes. Okay. So okay. So if I want data in a hierarchy, so rest of the node. A faulty process, it will be saying my number is X. So X doesn't exist, right? Yes. Another process is created. Okay. Hence, here we get 4 processes. So basically, cornerstones of a fault tolerance in distributed system. Having a TCP and UDP, guys.
Hello student. Today in distributed DBMS reliability, I will explain you the failures in distributed DBMS. Designing a reliable system that can recover from failures requires identifying the types of failures with which the system has to deal. Here we reviewed the major reason of failures in distributed computer system. Commands that are passed to the LRM. Hello student. Today in distributed DBMS reliability, I will explain you the failures in distributed DBMS. Designing a reliable system that can recover from failures requires identifying the types of failures with which the system has to deal. Here we reviewed the major reason of failures in distributed computer system. Number 1, transaction failures. The transaction can fail for a number of reasons. Failures can be due to an error in the transaction caused by incorrect input data. Reason: error in the transaction, potential deadlock, etc. Approach to handle such failure is to abort the transactions. Second is site failures, which is also called system failure. The reason for system failure constituted the bulk of our discussion in this section. It can be traced back to a hardware failure or to a software failure. Reason: hardware and software failure. Result in loss of main memory, processor failures, or power supply failure, site become unreachable from other site. Total failure and partial failures. So system failure due to hardware and software. Transaction failure due to error in transactions. Now the third one is media failure, that is also called disk failures. Media failures refer to the failures of the secondary storage devices that store the database. Such failure may be due to operating system error as well as to hardware faults such as head crashes or controller failures. Here we specify the reason of media failures, that is operating system error, hardware faults such as head crashes or control failures. So refer to secondary storage devices that store the database, result in either all or part of the database being inaccessible or destroyed. And the fourth one is communication failures. The three types of failure described above are common to both centralized and distributed DBMS. Communication failures, however, are unique to the distributed case. There are a number of types of communication failures. The most common one are the error in the messages, improperly ordered messages, lost messages, and line failures. So in communication failures types, lost, which is undeliverable messages, and communications line failures. Network partitioning. In network partitioning, if the network is partitioned, the site in each partition may continue to operate. Executing transactions that access the data stored in multiple partitions become a major issues. Lost or undeliverable message are typically consequence of communication line failure or destination site failure. If a communication line fails, in addition to losing the messages in transit, it may also divide the network into two or more disjoint groups. This is called network partitioning. Network partition points to a unique aspect of failure in distributed computer. Next is local reliability protocol. Local reliability protocol. In local reliability protocol, the function performed by the local recovery manager, which is denoted with LRM, that exists at each site. These functions maintain the atomicity and durability properties of local transactions. They relate to the execution of the commands that are passed to the LRM, which are begin transaction, read and write, and commit and abort. Second is architectural consideration. In architectural consideration, it is divided into two parts: volatile storage and stable storage. In volatile storage, it consists of the main memory of the computer system, that is also called RAM, the database kept in volatile storage in volatile database. Second one is storage, stable storage. The database is stored permanently on the secondary storage, which is in this context is called stable storage. Database is permanently stored in the secondary storage. The database kept in volatile storage is a stable database. Resilient to failures, hence less frequent failures. Stable storage. In today's technique, stable storage is typically implemented by means of duplexed magnetic disk, which store duplicate copies of data that are always kept mutually consistent, that is, copies are identical. We call the version of the database that is kept on stable storage the stable database. The unit of the storage and access of the stable database is typically a page. This figure shows the interface between the LRM and buffer manager. That means local recovery manager and the buffer manager. When LRM want to read a page of the data on behalf of a transaction, strictly speaking, on behalf of some operation of a transaction, it issues a fetch command indicating the page that it want to read. The buffer manager check to see if that page is already in the buffer due to a previous fetch command from another transaction, and if so, make it available for that transaction. If not, it read the page from the stable database into an empty database buffer. If no empty buffer exists, it select one of the buffer pages to write back to stable storage and read the request stable database page into that buffer. There are several different algorithms by which the buffer manager may choose the buffer page to be replaced. This buffer manager also provides the interface by which the LRM can force it to write back some of the buffer pages. This can be accomplished by means of the flush command, which specifies the buffer page that the LRM want to be. Next one is recovery information. In recovery information, when a system failure occurs, the volatile database is lost. When system failure occurs, the volatile database is lost. DBMS must maintain some information about its state at each time of failures to be able to
either you take it for granted because your database guarantees that out of the box, otherwise you just know it theoretically. So in this one, what we or in this two-part video series, what I would want to do is I would want to walk you through the concept of distributed transactions and implement it using two-phase commit protocol. We'll take an example of Zomato's 10-minute food delivery to understand the overall algorithm, the overall protocol to guarantee atomicity spanning microservices. Right? And in the next video, we will actually simulate this entire environment locally to understand this distributed transaction and to see distributed transactions in action. Right? So let's jump into the first part where we solidify our understanding of two-phase commit protocol using Zomato's 10-minute food delivery as an example. Right? So how Zomato in India guarantees, like, is about to guarantee 10-minute food delivery. So how would it do that? So Zomato purchases a lot of food in bulk from the restaurant because they have the data to understand, hey, from this area, at this time, this particular food will be ordered. They can predict a load on a particular food item, or the amount of orders on a particular type of food, so they can pre-book it or pre-purchase that food and keep them available in the store. Like, and they have these mini dark stores across all the cities. They have this micro store for each locality. So whenever an order is placed, the food is just already available in the Zomato store. They will just take 2 minutes to warm the food, and then they will have 8 minutes to deliver the food to the customer. So in 10 minutes, they can guarantee food delivery in India. Right, so this is what they are, basically this is from the business side of thing. Now let's talk about how you would want to, like, as an engineer, how you will need to ensure that you guarantee 10-minute food delivery. Like, what are the engineering challenges to do it? So to guarantee food delivery under 10 minutes, what Zomato should be doing is Zomato should be accepting the order for a 10-minute food delivery only when the food is available in the store. Right? Let's say you are ordering a burger. That particular burger from that particular restaurant is actually available in the Zomato store. Right? That burger needs to be available for you to place the order. And
hello,
right,
hey
so
guys,
if
welcome to
either of the two is not there,
and this
either
is
the food
Shreyansh
is not
Jain.
there or delivery partner is not there, you cannot guarantee a 10-minute food delivery, because if the food is not available in the store, then it needs to be picked up from the restaurant, which might be far away, and then delivered to the user. And if the delivery partner is not available and the food is there, hey, then how will you even deliver it within 10 minutes? That's the concept. So this is a classic case of distributed transaction, where let's say hypothetically that flow looks like this. You as a user want to place an order, the request comes to your order service. It is about to place an order in this database which stores all the user orders. But order service, what it would need to do is it would need to talk to the store service to reserve a food for an order, like to basically mark that this food is for this order and this delivery partner is for this order. So both of these things should be done, that the food should be blocked for an order and the delivery partner should be assigned to an order, and then only you'll say to the user that, hey, the order is placed. So you as an engineer, let's say you're building this order service out, right, which would work, like which would be placing an order only when these two are. Otherwise you would not place a 10-minute guaranteed order here. Right? So the one thing that a distributed transaction would definitely need to get, which is the toughest of all, is atomicity, which says that, hey, in one transaction, if I'm saying that there are 2 steps, either all of those steps happen or none of those steps happen. Right? So either all or none. Right? So here, if we take an example, if we extend our example and say that, hey, for the order service to work, order service will talk to the store service to reserve a food for a particular order. Okay, hey, this food is now assigned to this order. Like if it makes, like let's say the 3 services talk with simple HTTP protocol, like HTTP REST-based protocol. So order service makes a call to the store service on an HTTP endpoint and says that, hey, assign this food for this order. And then it makes another call to delivery service saying that, hey, assign a delivery partner to this order. But say that store service, that the assigning of food to this order is done, but delivery partner assignment failed. What does this mean? The store got the order, but delivery agent is not assigned, which means that the store started warming the food item and then basically